Today I'm going to talk about segmented regression and how to develop a segmented linear regression model in R. So segmented regression is a method in regression analysis where the independent variable is partitioned into intervals and a separate line segment is fit to each interval. It can be applied when the independent variables are clustered into different groups and exhibit different relationships between the variables in those regions. For example, you can see that the trend of the data in this scatter plot seems to change at this point, right? And this common point is called breakpoint. Breakpoint is very important. Hi.
Hello.
Hello.
Are you busy?
Kind of. I'm recording. So breakpoint is very important. If we can choose a very good breakpoint, then the R square is going to be very good. So how can we find the breakpoint? We can either find the best breakpoint iteratively, or we can just eyeball the breakpoint. For example, the breakpoint here is probably around 70 here, right? It depends on the analysis. So segmented regression equation. Y cap is equal to beta 0 plus beta 1 times x1 plus beta 2 times x1 minus x superscript k multiplied by xk. So let's look at the definition of these variables. x1 is a value of the independent variable. X superscript k is the value of the knot, which is the breakpoint, the value of the breakpoint. And xk is a dominant variable. This one should be dominant variable, sorry. So what is dominant variable? Actually, dominant variable is a binary variable. If x1, let me write this down. If x1 is greater than x superscript k, then the dominant variable equals to 1. If x1 is less than x superscript k, then xk is equal to 0. This is dominant variable. So let's look at the example. For Mingman has owned a used car lot in Manhattan for many years. As a successful businesswoman, she would like to track how many cars a salesperson sells per week and their total sales. She would like to examine the relationship between how many cars have been sold by each salesperson and how many weeks each salesperson has worked for this company. Let me erase this. So this is our data. The left column is job tenure, and the right column is total car sold. Our goal here is to find a model that can will fit this data. For example, the first salesperson has been working in this company for 168 weeks, and the total car sold is 272, which is not bad. I mean, it's more than one car in a week, right? The second salesman has been working here for 4 and 28 weeks. However, the car he has sold is 300, which is less than one car in a week, right? And first thing I wanted to do is to graph this data. So this is our data. The x-axis is job tenure, and how many weeks a salesperson has been working here. The y-axis is the total number of the cars the salesman has been sold. And we can see from the scatter plot that it is obvious that this is not a linear model, right? But it looks like a segmented model. According to our definition, we can see that these two linear lines seems to be connected at this common point, which is about 350. So this is what I'm going to decide. I'm going to decide that our breakpoint is 350. So I create another table here. First is the job tenure, our independent variable, and our breakpoint is 350. So this is our domino, because 168 is less than 350. The domino equals to 0, right? And for 28 is greater than 300, so our domino is equal to 1. And we also need to calculate this part. So for instance, the first salesman, he has been working here for 168 weeks. Our breakpoint is 350. The domino is 0. So this is 0. Let's look at another example. The second salesman has been working here for 428 weeks. Our breakpoint is 350, and the domino is equal to 1, which is 78. Okay. This is how I get the segment regression using R. First, I read the CSV data. This is job tenure. That is how many weeks a salesperson has been working here, and the total cars that has been sold. And then I set a vector, a 0 vector. And I set the name of the 0 vector as domino. And if the job tenure, that is how many weeks a salesperson has been working here, is greater than 350, then I set 0 to 1. So this is our new domino vector here. I also wanted to add another column to the original table. What I did is I used a dollar sign here. So I want to add the job tenure minus 350 to the new table, and I refer this value to x diff, which means the difference between 350 and the total car, the total sold cars. So we can get the table here. I also wanted to add domino as a new column to the data set. I did the same thing. I used the dollar sign again, and boom, I can get the new data table. And last thing, I wanna refer this to our new variable, the capital X. The capital X equals to the dominant times X diff. So I can get the value here, which is exactly the same as the table I showed you before. And I can run my regression now. I'm going to use linear model. Y is the total cars sold. X1 is job tenure. X2 is our capital X. And the data is read from the CSV file. So you see we can get the coefficients here. And let's run summary. We can see from here that the model is significant. The variables are significant. The relative standard error are 32. The R square is close to 0.9. The F is 62. It's really good, right? It's pretty good. So we can say that our model is this. So how can we get these two guys? If x, remember I told you that xk is a binary variable. If xk is equal to 0, we can get this guy here. If xk is equal to 1, we can get this guy here, right? So I guess we're done. Thank you. Next, I'm going to show you a very brief video of how to produce a model in R. So I guess that's all. I want to go through the PowerPoint to see if I missed something. Yeah, so for this scatter plot, you might think that this one looks like quadratic model, right? We can also try quadratic model and to compare the R square and the ANOVA table with a segmented model to see which one fits better. Yeah, I think that's all. Thank you.